Hi, so today I'm just going to be talking about and examining alien numbers. And part of when I look at this picture, some things that I came across were just looking at one. It's neither prime nor is it composite because one itself is just divisible by itself. That's why it's not a prime number. One itself is not a composite number because it is already in its simplest form, so it can't be broken down into its prime factors. And when I look at four is definitely it's divided into two pieces, whereas two is just a single colored yellow ring. And what I discovered is it's because four is a multiple of two, every even number goes up by two. And that number has yellow in it. So 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, and so forth. And when we look at 2 and 3 and 5 and 7, those are single colored rings because those are prime numbers that are not divisible by any number other than itself. So that's why it's not divided into pieces like the other numbers. And when I look at 11, 13, 17, 19, and so on, those are shaded red to indicate that they're prime numbers, and they're just kept, the code is the same, it's red, because it's too much. Otherwise, if they were to color code everything, you could, but it would complicate things. So if you look at 22 here, it's 11. So whichever prime number they're using for a 2-digit, they would indicate by writing the number here. So it would be 11 here, or 13 here, 19 here, and so forth. And so today we're going to figure out the pattern for numbers that are above 50 and beyond. So what are some ways that I would do this? Well, starting off, I would look at 51 and I would see, okay, so I'm going to start off with the low numbers. So I'm going to try and divide 51 by 3. So 3 can go into 5 one time. So then I would subtract that and I'd be left with 3, and then that would be 2, and then I would bring down the 1. So 3 can go into 21 7 times. So then I'm left with 0 because 21 minus 21 is 0, so I'm not left with anything. And if I look at these numbers, 3 is a prime number because it can't be divisible by any number other than itself, and 17 itself is a prime number. So if I go back to my chart, 3 is here, shaded green, 17 is also red, so perfect, I can shade those numbers in. Yeah, so I will shade in red here, and for the 3, it will be green as here, indicated here. Pardon my rough drawing. Okay, and then 52, same thing. So I'm going to start off low. So I think that 52 will be divisible by 2. So I'm going to see how many times can 2 go into 5. It can go into 5 2 times. So then I'm going to subtract 4 from 5 because 2 times 2 is 4. And then I'm going to subtract 5 minus 4 1. And then I'm going to bring down the 2. And that is going to give me 12. So how many times can 2 go into 12? Well, it can go into 12 6 times. So I'll rewrite that 6 times. And I am then left with 0, which tells me that I'm done. However, when I look at 26, it tells me that I can further reduce it because it's not in its simplest terms. It can still be divided further into its prime factor. So I'm going to divide 26 by 2 once again. 2 can go into 2 once, so 2 minus 2 is 0. So I'm not going to write that. And then I'm going to bring down the 6. And how many times can 2 go into 6? It can go into 6 3 times. 6 minus 6 is 0. Therefore, done. So when I look at 13, one way to check whether it's a prime number or not is to go to my chart. Yes, it's red, it's prime. Another way is to think about 13 itself. Is it divisible by any other number? No, it's not. So the factors for 52 are going to be 2 and 2 and 13. So that means that I should have 2 yellows and 1 red shaded in here. So 2 yellows and 1 red. Moving on to 53, so I'll write 253 up here for just because of space. 53, when I do this, oops, I can write that better. 53, so if I look at this, let's see if it works with 3. 3 times 1 is 3. Okay, subtract 23. How many times can 3 go into 23? Well, it can go, but for now I can definitely tell that it will go into 23 evenly. So it will have remainders. So we're looking for numbers that are going to have, that can be broken down into its prime numbers. So, or numbers that can be divisible evenly. So for now, by looking at the ring, I can definitely tell that it has no factors. It's not divided into anything. And from my math, I can tell that, hey, it's not going to divide evenly. So judging from this chart, the pattern here as well, I see that it's 53 is going to be shaded red. And moving on, if I look at 59, 59 is also going to be one number that is going to be shaded red because it's a prime number. How do I know? Well, it has no factors in it. There's no rings that divide it up, or no parts that divide up the ring. So now moving on to 54. If I were to divide 54, okay, so let's try 54 by 3. So 3 times 1 is 3, and I'm going to subtract that. So I am left with 24. 3 can go into 24 8 times, so 24 minus 24 is 0, which means it's done. So definitely I know that 3 is a prime number. 18, I further know I can simplify that into its prime factors, so I'm just going to do it here. So if I divide that by 3, I will get 6. 6 times 3 is 18. And I am left with 0. Okay, so then 3 is also a prime factor, but then if I look at 6, 6 is not. So that means I probably have to do the 6 again, because if I look up the chart, 6 is divisible into 2 factors, so I will do that one again. So I will divide that by 2 again. 2 times 3 is 6, so I'm going to do the math here, just like I've done before. 6 minus 6 is 0, left with 0. So again, 2 is a prime number, and so is 3. So the numbers that I shade in here are going to be my 3 greens, because I have 3 threes. So 3 greens and 1 yellow for 2, which I'm going to use this highlighter. Okay, 55. Well, 55 to me, when I think about it, 55, when it's, let's try and divide by 11. 11 can go into 55 5 times, so I should be left with 0. Okay, so the numbers that I'm going to shade in are going to be red for 11 and blue for that color, which is 5. And then 56, moving on, if I were to do that for 56, okay, so if I were to divide 56, so I'm going to use 7. 7 times 8 is 56. So then if I look at my 7, 7 is a prime number. It's not divisible by anything other than itself, or 1. 8, I know I can reduce further. So if I were to divide 8, I know that 2 times 4 is 8. So then I am left with 0. However, I know that 4 is something that can be reduced even further. So it can be divisible by 2. It's not in its simplest form. So 2 times 2 is 4, which means that I will be left with 0. So the factors that I've highlighted are 7. So 7 is going to be one of them, 2 is going to be one of them, and then 2 2's from here, which means 56 is going to have 3 yellows and 1 purple. So 3 yellows, and I don't think there is purple, so I'm going to stick with this magenta. Close enough. 57. Now if I were to divide that, so I'm just going to erase this off to make sure I have enough space. Okay, so if I were to divide 57, okay, 57 can be divisible by, let's see, 3, 2, 1, 6, ignore the line please, 3, okay, that just went wrong. Okay, so it's 1 minus 3, 2, 7, 9 times 3 is 27, so I write that, and I am left with 0. And therefore, 19 and 3 are most probably going to be my factors, because 19 and 3, if you look, are my prime factors here. So 19 is here, 3 is here. So 1 is going to be red, and 1 is going to be green. Now moving on to 58. 58 is, if I were to divide that, so that's a bit too dark. 58, if I were to do that, if I divide that by 2, so 2 times 2 is 4, so subtract that, and then I'm left with 18. 2 times 9 is 18. 18 minus 18 is 0, so I'm left with nothing, which means my prime numbers are 2 and 29. We can check here as well, 2 and 29. So great. 29 is red, 2 is yellow, so 2 is here, and 10 is here. There we go, red. So now moving on to 60. 60 is a long one. 60, if we were to do that, 60 is, if we divide 60 by 3, so I know that 3 times 2 is 6, and bring down the 0, put the 0 up there, and yeah, so 3 times 2 is 60, 20 times 3 is 60, and then once I know that 20 cannot be divisible by, 20, we can reduce it further, so I'm just going to divide that by 2, and I'm left with 10. So then that tells me that, so based on the math, so I'm left with 0. Just as a shortcut, because I've explained the steps before, so this should make sense. 10 can further, if we divide 10 by 2, it can be reduced further by 5. So the factors that I have here are going to be 5, 2, 2, and 3. Hence we have 4 numbers. So I'm going to shade 2 yellows for 2 2's, and 1 green and 1 blue. So 1 blue here and 1 green here. So that explains that part. So so that was my pattern. So thank you for listening and tuning in. Hopefully I was able to explain my mathematical processing the way I should have, or at least the way that I thought about it. So so thank you.